is just a plain old simplifying one. So our GCF difference of squares, all the numerators, all the denominators, right? We have rules for each when we see. What we see, we do. So for this one, I can take out a 5 and an x, and I'm left with 2 minus x. And this 5 and the x, the GCFs are always your monomials. In the denominator, I can take out a 3x, and I'm left with x minus 2. So my non-permissible values come from the denominator. They're going to be x can equal 0 because of the x, not because of the 3. 3 doesn't cause me any problems. It's only variables. And 2. Okay, can these cancel off, the 2 minus x and the x minus 2? One's a positive 2 and a negative x. One's a positive x and a negative 2. They can't cancel currently. What can I take out? Everyone paying attention? You take out a negative 1. So you can take it out of the top or the bottom, it doesn't matter. I'm going to take it out of the top, so make it a negative 5. This will become a negative 2. This will become a positive x. So I should have taken a negative 5x out, not just a 5x, correct? Negative 5x would have changed the signs. Now these cancel because they have the same signs. The x's cancel. And my answer is negative 5/3, followed behind with x can't equal 0 or 2. The next one is subtraction. When I subtract, I need what? Common denominator. What's common to x plus 3 and x minus 2? Nothing. So I need to multiply this one by x minus 2. And this one by x plus 3. Okay, all the talking has to stop. All right. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Negative 3 times x is negative 3x. Negative 3 and negative 2 is positive 6. All over x plus 3, x minus 2. Remembering that we don't distribute the denominators because they're already like terms. You're making it more complex if you actually collect them. Okay, then we get x times x is x squared. X times 3 is 3x. 6 times x is 6x. And 6 times 3 is 18. All over x plus 3, x minus 2. Now we have a common denominator, so we can write them all over that. X plus 3, x minus 2. We have subtraction that we can make sure that we distribute through. So we get 2x squared minus 4x minus 3x plus 6. Minus x squared minus 3x minus 6x minus 18. So it changes all the signs behind it. Then I collect like terms. 2 x-rays minus an x-ray is 1 x-ray. Negative 4 xylophones minus 3 xylophones is negative 7. Minus 3 is negative 10. Minus 6 is negative 16 xylophones. And then 6 minus 18 is negative 12. All over x plus 3, x minus 2. What are my non-permissible values? X can't equal what? Negative 3 and 2. Number 3. The numerator on the left-hand side is a difference of squares. Remember, it's when it's a 1, people forget about it. 4a squared, the square root is 2a, and 1 is 1. So I'm going to get 2a plus 1, 2a minus 1. This one, you have to take a 4 out first. A squared minus 4. If I take the 4 out, I still have a difference of squares. If you forget to take the 4 out, you're going to have to take a 2 out, and then make it a 4, which is way more complicated and people mess up. So, we're taking a 4 out, and then you have a difference of squares of a plus 2, a minus 2. And you multiply. I need a minus 2, not positive 2 minus a, so I'm going to need to take a negative 1 out. And then I'm left with a minus 2, it changes the sign. And then the denominator is 2a minus 1. Remember, your non-permissible values come for a division by everything but the top left. Yeah?
Is 4a squared minus 16 not a difference of squares?
It is, but then you're going to have a 2 in both of them that you're going to be able to take out. Because you're going to get a 2a plus 4, 2a minus 4. Have to take out a 2, have to take out a 2, and you get a 4. So it's easier if you just GCF the 4 out first, and then do the difference of squares. So we have a plus 2 can't equal 0, a minus 2 can't equal 0, 2a minus 1 can't equal 0. So a can't equal negative 2, a can't equal 2, 2a can't equal 1, divide by 2, a can't equal a half. Then we have full numerator, full denominator, because we can minus multiplication. Those cancel, and I'm left with negative 1, 2a plus 1, over 4a plus 2. A can't equal plus or minus 2 and a half. So had you not taken the 4 out first, you would have ended up with 2a plus 4, 2a minus 4. You have to go to 2 and a 2 and make that a 4, right? In order for them to cancel properly. It's a lot easier if you just GCF first before you do a difference of squares. All right, then we're going to flip to our polynomials. Go back to your booklet where we left off. All right, so go to your y equals, clear it out. First thing we do whenever we start a question. Go to our y equals and we clear it out. And then we go stat, edit. Here are your lists. Let's start over again. Tomorrow we're going over our last lesson of this unit. So on Tuesday will be your open book. Yeah. Then we move on to logs and exponentials. You have to have a unit test on the 2 units as well. I could put the test on Monday, but then everyone would hate me. So I'm putting the test on Tuesday in order to not have hateful. See? Not my first rodeo. 20 years in, and I know not Mondays make people angry. All right. Sometimes it just has to happen, but this one we can do Tuesday. Okay, stat, calc, we're trying to find linear. And it gives me y equals, and I said you don't have to round to nearest hundredths or whatever, you can just write the whole thing for now. It'd be y equals negative 0.1 though if you are rounding to nearest hundredth, x plus 10 decimal 03. Am I allowed to use that in my y equals, the rounded version? No, if you use the rounded version, your answers will be off by a few decimals, right? And if it's a numeric response, you're in trouble, or a written response. So that's why we always have to know how to plug it into our y equals. The other thing on a test is I can literally just ask you for the a or b. I could say an equation in the form y equals ax plus b, the value of b to the nearest whole number. It'd be 10. That's it. Sometimes that's as easy as the question is. I don't even make you do work. Okay? Very minimal. So we want to get it into our y equals. So we go y equals var statistics over to equation, enter, and we have it sitting in our y equals. And then we always do what next before we touch the question? Change our window to suit the data, right? I know windows suck normally. They're like the worst things ever. I don't deny that. I hated windows in high school too. But these aren't so bad. They at least give you some numbers, right? Put something above the highest, put something below the lowest, and call it a day, right? So here we are the world record in a 100-meter sprint since 1960. So these are the years after 1960. So, yeah. So we're going to go to window, and we can make our x min be negative 10, which would represent 1950. Yeah. Yeah. And then we have 49. We could make it be our x max be 60, let's say. So we could make our x min be negative 10, and that would represent 1950 in this question, because 0 is 1960, right? We can make our x max, everyone should be doing this, 60, or we can make it higher, make it be 100. Our x scale, we can make be 5, or if you're stuck, you can always make your x scale just be a 1, right? Don't overthink it. You just might not see any ticks, because it'd be like 70 ticks in the little screen. Our y min, what's the lowest you could go in time? What is time? The lowest. 0. We haven't learned how to time travel yet. or at least not been informed of it. Y max on this one is 10, so I could make it be like 15. My Y scale be 1. Or 2 or 3, whatever you want. And then I press graph, and I should see some sort of line. Yes? Okay, let's look at B. B says, what does the y-intercept represent? The y-intercept is when x is 0, correct? So this would be the y-intercept. It's at 0 and 10 seconds. What does that represent in the context of this question? What is 0 for years in this question? 1960. So in the context of this question, it would say the world record time for the men's 100 writing this down. Sprint was 10 seconds in 1960, which is what they wrote above. That's what it actually represents. Then I had you do C. Remember, the questions I give you after this could be, I give you an X, I want a Y, or I give you a Y, I want an X. If I give you an X, we're paying attention. If I give you an X, we do second trace value. X equals pops up, we put in an X. If I give you a Y, you put it into your Y2, find out where they intersect. Correct? If there's an error, like you can't find out where they intersect, it's probably because your calculator can't see where they intersect. So then a lot of people move everything on their window. No, just change your X max. 97% of the time that will help it. Probably 99.9 actually, changing just your X max. So we want the world record in 2007. 2007 is the X. So people put 2007 in for X. Would that work? It's after 1960, correct? So what are we going to do to get our actual X? What math? 2007. What? Minus 1960, because it's years after 1960, which is 47. If I put in 2007, that's actually 2007 years after 1960. Is that what it wanted? No. We had questions before where it actually kept the years, like 1994 or 1996, and that's what you put in. But this one doesn't have that. It says years after 1960, so you really have to read your questions to see what they want. So that means I know X. So I go second, trace, value, 47. If it errors me, that means my X max is probably less than 47 and it can't calculate it. Because it can only calculate what it can see. All right. So I got Y equals 9.72 seconds. If you said 9.7, if you said 10, because you rounded up, I didn't give you a rounding rule so you wouldn't be wrong. But on a test, I'll tell you what to round to. Okay? So I rounded to the nearest hundredth. Hundredth is 2 decimal places. So I have to have a sentence. The world record time in 2007 was 9.72 seconds. Then here it says, what year, so now it wants X, what year did the sprinter's speed drop below 9.89? So in order for it to drop below 9.89, I'm going to get whatever year it is and then round up because it's going to take me to the next year to make it drop below that. Okay? So they gave me Y. How do I know they gave me Y? Because the unit is in seconds, and on my table, seconds is sitting in the Y column. Correct? I can tell it based off my units. Where do I put a Y if I know Y? Into Y2. Don't clear out your equation. It goes into Y2, 9.89, and then graph. Now some people are like, I don't know if it's crossing or not. Always go second trace 5, enter, enter, enter right after, because just because you can't see it doesn't mean your calculator can't, so I always check anyways. So I go second trace 5, enter, enter, enter. And I get 9.8, oh, I get 21.47. So what would I round up to make it go below? 22 years after 1960. So what would the year actually be? 1960 plus 22. So it's actually 1982, which is when my husband was born. I, the spring chicken, was born in 83. So he's way older than me. At least a year and a month. He's August 8th, I'm September 8th. So he's ancient and I'm a spring chicken. All right. So in 1982, sprinter speed dropped below 9.89 seconds. Okay, then I told you domain and range we'll do later. So, plug in example 4. Sat edit 4. So you're going to have y equals 404.89 x minus 300.36. We want to make sure we have it into our y equals, not that rounded version, the whole version. We want to make sure we have a window. So we're going to talk about the window to help us with domain and range. Okay? Now let's think about this. This is a line. This line is just going across the page, correct? So in order for it to be a line, it's like down here. Okay? But what part of it matters? So number of events. So here, let's talk about this. Devin is on a budget. He's trying to decide how many grad events, because he's a show-off, he can afford to attend this year. He interviewed 15 of his older brother's friends to see, this is hilarious, how much money they spent compared to the number of events they attended. All right. So, guys, domain is X, correct? So we have to talk about minimums and maximums, yes? The X is based off of number of events. What is the minimum number of events he could do? 0. He could literally do none, right? He could attend nothing. Is it true? Okay. So I know my X minimum for number of events is 0 events. Okay. What is his X maximum? Is there a limit on what he can do? Or is there an infinite number of events he could do? He doesn't have like an amount that he's limited to, right? So there's an infinite number of events. Let's talk about our Y min. Money. What is the minimum amount of money he could spend? 0. He could go nowhere, spend nothing. Yeah? Does he have a maximum amount he can spend? Did it say in there he has a maximum amount of any sort? Does it say up here there's a maximum amount he can spend? No. So that's an infinite number of money. Correct? Do we agree? So, if we talk about the domain for this question, and I want to put this into some sort of domain, I'm going to say x such that, what's the lowest he can be? 0 to infinite, correct? What does that mean as a domain? X is greater than or equal to what? 0. X the noun in the reals. And my range is the y's. What's the minimum my y can be? What does it say? 0 or to infinity. So what does that mean? Y is greater than or equal to 0, YER. Now some people will say to me, but Mrs. Lepp, linear equations, disco, and discoing equations are XER, YER. That's true. I said unless it's a word problem. Because word problems can have restrictions based off of money, time, temperature, stuff like that. Okay? Now, here it says Devin estimates that he has about $750. Is that X or Y? It's Y, because look at the units. Dollars is in Y, correct? So that's my Y2. So I go to my Y2, and I make it 750. Now remember, you have to make your window fit the data, right? So I'm going to go second, trace 5, enter, enter, enter. Now this is the catch you have to watch. It says he can go to 2.5941 blah 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 events with $750, correct? Now everyone uses rounding rules and they tell me he can go to 3. Can he actually go to 3 with 750? No, he can go to 2 and then still have some money left over. That's all he can do, right? Like if you need $1,500 to buy a car and you have $1,499, can you buy the car? No, you're going to buy a cheaper car and you just get to save money. That's it. You get a pedal bike or something. All right. Electric bikes are more money than that. Okay. So X equals 2. So Devin can go to 2 events. Making a little more sense? All right, flip over. Starting a new question, what do we do? First, go to our y equals and clear them before we start any question. Then stat, edit, clear, enter, clear, enter. We're answering all these questions, including H now. This was the last one I gave you yesterday. Try and answer them. Let's do a little discussion. So, this is quadratic. We had to pick number 5 this time, right? We can't pick linear. We're going to have y equals negative 10.07 x squared plus 51.41 x plus 11. Okay, I'm going to change my window. Let's talk about the window. We're talking about a golf ball. Okay, so I know I'm going to go from like 0 to 10, let's say, and then 1, and then 0 to 100 maybe. See if I can see the golf ball actually going in. If you don't see anything, people will call me over and they're like, Mrs. Lepp, my window is perfect, and I cannot see it. You call me over on a test. And then I usually just go up to your calculator and I press the y equals. And it's usually empty. And then you go, because you didn't put a equation in the y equals, right? So even though your window's beautiful, you have no equation to graph, so it won't graph it. So always, or you're graphing an old equation, right? But if you remember between every question, you go to your y equals and you clear them out, you won't make that oopsie. If you don't clear them out, you might answer 4 questions off the same equation. That is not the right one. Okay. So I see something on my graph like this. We're going to go down to H first. I see something like this. Okay? What is the x values? Time in seconds. We agree? So this is time in seconds. So my domain is not going to be XER. So what time do we start at for this golf ball? What time do we start at? What time do we start at? 0 seconds. What time do we end at? We need to find that, correct? That's the x-intercept. That's when y equals 0, yeah? So go to your y2 and put in 0. Everyone do this. y2, put in 0. Then press graph. Remember, if you have the colored calculators, it shows up. If you have the non-colored calculators, I always make it a thicker line. I really wish like I said, my calculators were correct for talking. Anyways, so it's going to be on your x-axis, yes? So you want to find out where it intersects with that second one. You want to find this. So right now your y1 is this equation, the quadratic, and your y2 is now a line like this, right? You want to find this intersection. So we're going to go second trace 5, and we're going to arrow till we're blinking near this intersection. And then just go enter, enter, enter. And I get 5.31. Did everyone do that? Because you should all be practicing it. So I got when it hit the ground, it was 5.31 seconds. Did everyone else get that? So then my domain is between 0 and 5.31. So when I go to do my domain, it's going to be x such that, and when it's sandwiched between two values, you go low to high, less than or equal to signs. So I'm going to go 0 is less than or equal to x is less than or equal to 5.31. X is an element of the reals. Okay? Now we're going to discuss the range. What is y? Y is height in meters. Do you see that? So this is height in meters. What height did I start at with the golf ball? Well, where does it end at? It goes up and then it comes all the way down to 0 meters, correct? So 0 meters is the lowest the golf ball can go. How do I find the highest? What do I have to find? The maximum. So let's go do it again. Second trace max, number 4. Second trace maximum, let's all do it. So I need to be on the left side of the maximum, hit enter, be on the right side of the maximum, hit enter, and then guess I hit enter again. So this is 2.55x, which is seconds, comma, 76.60 meters. You see that? So what's the highest it goes? A lot of people will tell me 2.55 seconds. That's how long it takes to reach the highest. What is the highest it goes? 76.60 meters. Do you see that? So it's the y, because we're looking at y's, because it's range. So our y is between 0 and 76.6. Y such that 0 is less than or equal to y is less than or equal to 76.6 meters. I don't know why I put the M. Y-E-R. Yeah. Does that make sense? That we're flanking it because it goes up and then it comes back down. It's not for forever. We can answer E and F now. E says, what is the maximum height the ball reaches? What was the maximum height it reached? 76.60 meters. We can also answer F. At what time does the ball reach maximum height? 2.55 seconds. It's this one. Yeah? Let's go back and answer other ones. Here it says, use the equation above to determine the height of the ball at 2.5 seconds. Did they give me X or Y? Did they give me X or Y? Look at the table. They gave me X. Yes? Paying attention. So I have X equals 2.5. Where is an input for X? What do I do to input an X? Second trace value, x equals pops up, and I put 2.5. And it's going to be y equals 76.575 meters. Okay? What's the next one? Is it an x or a y? 4.5 seconds. X, because units of seconds is x. So I do it again. Second, trace, value. Everyone's typing this in. It's not for me. I'm really good at these. Second trace value, 4.5. And I get y equals 38.39 meters. This one asks, when did the ball hit the ground? When it hits the ground, that's y2 equals 0. We already did this. When did it hit the ground? 5.31 seconds, right? We already found that. What time does the ball, they want what time, so x, does the ball reach a height of 60? And it says times. So y2 equals 60, because it's height. Type that in. Why does it say times? What times does it reach 60? Yeah. There's a time going up and there's a time going down. We have something like this, and then we have something like this. So we're going to have to go second trace 5, enter, 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 be close to this one. And then second trace 5, move over here, enter, enter, enter. Okay? Everyone's trying it out. Because you have to be able to use your calculator. No one else has your calculator and you for your test. Second trace 5, arrow over to the closest one to the y-axis first. Be blinking near it, and then go enter, enter, enter. And this first one happens at 1.27 seconds. And then I'm going to go second trace 5 and move over to the other one. We're doing this. Second trace 5, move over to your other one. Enter, enter, enter. And this one I get 3.84 seconds. So x equals 1.27 seconds, comma 3.84 seconds. And then G says, what is the height of the ball at the moment of release? The moment you release the ball, the moment you hit it. What does that mean? What is this a fancy way of saying? Time equals 0. And where does time go in for? X or Y? X. So I go second, trace, value, 0, enter. And what did you get? Second, trace, value, x equals 0, enter. What do you get? 11. Look, it's the y-intercept, right? That's just the y-intercept. What's my y-intercept? It's the constant at the back. It's the same number. Do you see that? So we found it as 11 off our calculator, but it's also 11 off of our standard form equation. Starting to make a little more sense? Okay, type this one in. It's a lot of data. Cubic, go. Here we have determine the cubic regression that represents the data to the nearest whole number where necessary. So we're going to have y equals, honestly, I'm worried with nearest whole number because this one would just be 0 and that's stupid. So I'm going to go 0.02. X cubed minus 0.465 x squared. I'm going to kibosh this. Plus 6.295 x plus 23.45. All right. So we change our window. 0, x max of 60, and then my y min of 0, my y max of, you could say 150. And I have a cubic function. All right. So here it says determine the year. Is year X or Y? X is actually years after 1979, so whatever we get, we have to add to 1979 to get the year, right? And then Y is price of gas. So it says determine the year which the average price of gas was 56 cents to the nearest tenth.
Thank you.
Okay, so Y2 is 56. So everyone's typing it in. Y2 is 56. Second, trace 5, enter, enter, enter. Now watch yourself. X is the nearest tenth, 16.5 years. But what year is that? What do I add it to? 1979, because year 0 is 1979. So I go 1979 plus 16.5 equals. And you get 1995.5. 1995 and a half. All right. Next one. I want you guys to do 7, 8, 9. Go. 7, 8, 9.